Hello there, hello and welcome. My name is GoodElk12. Today I'm going to be doing a little solve video on one of my own puzzles. So this is a puzzle I set called You Throw Yourself a Miss. It's inspired by one of my all-time favourite authors. I'm not going to tell you who right now, but I actually set this puzzle originally for a friend in America who goes by the tag Momcraft42. So there's an interesting, she also likes the same author, so there's an interesting hint on who that author is. But I'm just going to go through how to solve this puzzle and some techniques. So I'm going to just start that now. So this puzzle has a few different things in it. In fact, I should read you the rules. Standard Sudoku rules apply. Digits in arrows sum to the total in the circle or pills. The pills are the vertical two cell digits, and they read from top to bottom. Numbers on borders of cells denote the difference between the numbers. So like for instance here, this has got to be 2 different from that, and the same with all these. So they're the 2 different things. So I'm GoodElk12. Please like and subscribe and add a comment in the video. Please be kind, because I am sensitive, but I love talking about Sudoku and thinking about solving and also setting if I can. So this puzzle, I'd say it starts here, because this looks like something quite easy because we've already got a number in the clue set. Okay, so we can have a look at that in a moment. Those pills there. Okay. But then we've got this going down here and around here. So as well as these little arrow clues down here. So there's quite a few things going on in this puzzle, but it looks like we need to start from up there. Anyway, so first of all I'm going to have a little look at Sudoku, and I'm going to talk about Schneider. Is it Schneider? Eric Schneider, was it? Produced a theory for solving Sudoku. If you can find a location where 2 digits go, then it's good to mark. So let's have a little look at where 2 digits can go. Anywhere else. And because then if we imagined there wasn't a 5 there, for instance, and there was a 5 here and a 5 here, then we would know again there would be 2 5s. 5 would be in either of those boxes. They then would be a hidden double. So we could say that they would be 4 and 5, which we would mark using the center notation. So the outside notation is a restriction on 4s within the box. The inside notation I would notate all the digits with. So that's a good way to get on. But I'm going to do 3 cells as well in this puzzle, because it is a, what do they call them? It's not a pure Sudoku. So often 3 cells can also start to tell us something else. So I'm going to do that today, just because, oh, here's another 2 cell version. So the other thing, so just for the rule's sake, numbers cannot repeat, must be 1 to 9 in the top. 7, 8, 9. Oh, there we are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Could be, couldn't it? And same there, 1 to 9. And in each box it's 1 to 9 as well. Okay. And these pills add up to the number along these, and these also add up to the number along those. Anyway, so where else? 5s can go in there. So I'm just doing a little look around the a grid to see where numbers are restricted to, and then I will jump up and I will start looking at these. So we know 7 is 2 away from 7 is either 5 down or 9 up. So we can do 2 away. So 5 could go down to 4, except there's a 4 in the column. So it can only go to 6. 9 can't go to 10, but can go to 8. So 2, so 4. We can do 8 to 6, and we can do 6 to 8 there. And now we get the full set of even digits, because we can go 4 to 2, 6 to 4, 8 to 6, and we can do 6 to 8. We're getting them all set up here. But now this is interesting, because a jump of 6 is a big jump. Therefore, if this was a 4, it would either have to be -2 or 10, neither of which work in Sudoku. And also, if this was a 6, it would either have to be 0 or 12. So that doesn't work. So this is a 2 or 8. Again, because 6 away from 8 is 2, and 6 away from 2 is 8. And now, 2 away from 2 is 4, because you can't take 2 away, because you'd have 0. And there's already a 4 there, so we know what this digit is. Our first little digit there. How helpful. We've also got these 2 8s, but we're going to work out what that is now. 6, 8, 2, 4, 6, 5, 7. So this has got to be 4, because we can't go up to 8, because there's already an 8 in the row. This has got to be 2. So that's our little line. So we have made it that far. Now, why you throw yourself and miss? So let's have a little look at where this comes from. Now, my favourite author actually is, and prizes if you guessed it, is Douglas Adams. And this is, gonna do that. This is a comment from one of his books. I think it's from Life, the Universe and Everything, which is the 3rd in the trilogy. The trilogy in 5 parts, of course, because this is Douglas Adams. So he states, there is an art to flying, or rather a knack. The knack lies in learning how to throw yourself at the ground and miss. Clearly, it is the second part, the missing, that presents the difficulties. So this is from The Hitchhiker's Guide to the Galaxy, which is the digital book, which the book Hitchhiker's Guide to the Galaxy is all about. So back to there. Back up to full screen. And now, I should check everything is running good down here. We are looking good. We are looking good. Hair's a bit dodgy. Oh dear. What are you doing? Come on, GoodElk12. Pay attention. Anyway, so the idea of this puzzle is that we have made it to the edge of the cliff. This is the edge of the cliff. But you, this is us. You throw yourself. Okay, so we need to throw ourselves and miss. So we need something to throw ourselves at. So the next place which is good to go to in this puzzle is actually looking at the ground, because you need to miss the ground. That's the other thing in this puzzle. But also I can mark out some more digits going on. We can mark that there is a double in these, and it must be 3 and 9, so it doesn't say 1, 2, 3, 4, 5, 6. That was a ridiculous idea. So what else can we have? Look at this. 4 and 6, 4 and 6. So we know 4 and 6 have to be in there. And actually we've got a digit there, which is 4 and 6. Okay. So these have to be from 3, 9 and one other. 1. Is it 1? No, 1's there. Oh, 8. 8 is missing. There we are. 3, 9 and 8. Oh. and there is now a 7 here. Okay, so we're getting quite a bit going on here, and I feel it's important. This whole pair of top lines is quite important, so I'm going to look at what could be in both these cells. So 3 can't because it's down there, 8 can't, so this is actually has got 1 in it, and 9, and this one over here can be could it be everything? 1, 3, 8 and 9. Yeah. Okay, take away the naught, because that's not possible. But there's something else needs to be in here. Oh, okay. So the 8 is in one of those two, so that can't be 8. So we know that there is an 8 in one of these, and we've got 2 out of our 3 numbers in this bottom row. And there must be some things in here that aren't 1 and 9. So 1 and 9 could be either 1 or 9 could be in that bottom row. Oh well, one of them is. But we need 5 as well, but we've got 5 going on there. 1, 2, 3. Where's 3 then? Oh, 3 must be in here, so 3 must be in one of those. Okay. So that does mean 3 is on that arrow. Okay. That's a little bit helpful for when we get there. But I must have a quick look around to see if anything else. Oh, so that was 3 in this box somewhere there, because 3 must be between one of those, because 3's got to be in there. Okay, good. That's helpful. What else have we got going on? Any more? Well, I can't see it at the moment, so I'm going to have a look at the ground. Now, interestingly, when you have a circle, and we've got these 2 circles, then they have 3 digits on them. Now, what's the smallest this number could be? So 3 digits, 1 to 9, of course 1, 2 and 3, which add up to 6. Okay, so if they add up to 6, but I've missed something. I've missed that there must be a 4 in one of those 2 boxes, because we've now got 4 here, 4 here. Okay, and the same is true over here. But there's an interesting thing. I said that the minimum that could be is 6. Therefore, that can't be a 4. Now we get an interesting arrangement going on. Now we have an agreement. When you have 2 and 2 digits in 2 cells, then you have what's called an X-wing. And an X-wing, of course, it sees all the digits in its column. So we know 4 can't be anywhere else in the columns, okay, but we've already worked that out. But it also, if there is a 4 here, there must be a 4 there. If there's 4 there, then there must be a 4 there, which means there can't be a 4 in this bottom section of this box. So the 4 would be in the top 3. We know where the 4 is, so it's a bit academic. But that does tell us that there is a 4 on both these arrows. So 1, 2 and 3 doesn't work. So it can't be 6. It can't be 7, because I've got a 7 in the row. So it must be 8 or 9. Okay, so how do we make 8 or 9? So we have to make up 4 or 5. So 1, 3. 1, 3. So I know 3 can't go there. So 1 and 3 would make 8. And 2 and 3 would make 9. Can I put anything there? Well, 4 and 1 and 4 would make 9, but of course that's illegal. So this has to be a 3. Okay, so that's quite interesting. Puts a 3 in there. Puts a 5 in there. We now have a 1, 9, pair up there, and this is 8. Okay, so 7 is 1, 2 and 4. So can we do that? Let's try that. 1, 2, 1, 2 and 4. 3 is no longer available in there. So 8 would be 1, 3 and 4, but there's no room for 3 in here. Is there another way? There is a way to make it with 5, but of course we haven't got a 5 and there's no room for 5s either. So this is actually 7. That is 1, 2. We now though have a 1, 2 pair in this bottom row. So now we can look at these. Now, looking up, I see straight away. So, what can be here? 1, 2 can't. 3 can. Okay, we can put 3s in them. 6. 6 is missing. And I can see a 6 here, and I can see a 6 here, blocking that square from being a 6. So there's only one place the 6 can be, which is there. And now we have got 8 and 9 in there as well. So 8, 9. But that one, can that be 8, 9? That can be 8, 9. 1, 2, 8, 9. Oh no, that's wrong. Oops. 3, 8, 9. So we got those 3, 8, 9s. We got a triplet there. And we got 3, 8, 9 up there. So I'm looking at that now and I'm thinking, can 3, 8, 9 maybe anything? However, let's have a little think about this. So we got this 2 and this 7 up here, which haven't appeared in this box yet. What's going on? Okay, so we can have a 2 and a 7 in there as a double, so that's quite nice. So these must come from 1. 1 has got to be in there. 3, 8, 9, except we can't put a 3 in here. Okay, is that helpful? Okay, a little bit. Maybe later. So I feel like we're getting a good amount of earth going on this bottom row now. Got good ideas about what that is. Got good ideas about what's going on the top puzzle, but we have quite a lot down here that we haven't got filled in. So we got 5s on there. 3s, yeah. 7s, okay, got that already. What about 8s? 8's kind of around here. 2, yeah, no, not helpful. Okay, 7 already down there. Yeah, well, there's no 7. Oh, there's 7 there. Oh dear. Good, come on, wakey. So now we get to the important part of the puzzle, which is of course the leap. So kids, so of course, if you want to leap and find out if you can fly, do it onto a nice mattress. I used to have a mattress in the attic of my mum and dad's house. When I was growing up, that I used to practice my goalkeeper dives on. Well, 1 o'clock in the morning, my dad came up to find out what was going on. Strangely, but there we are. Right, so we got some things going on up in this top area. So we're going to jump off our cliff now. Yeah, don't do this at home. Right, and now this. We know this is a 20 something. So is this a 30 something or this a 90 something? Now, logic. I'm going to ask the question, is it a 30 something first? Because it feels unlikely that it would be a 30 something. Because 20. So if we consider what we've got here, we've got 20 something. How many numbers have we got to make it of it? So 4, 6, 8, 10, 12. So if we start thinking about averages, if this was 24 for instance, then the average number along these would be a 2, which is quite low. And even if this is a 9, the average is still 2 point something. It's still not that great. However, if we put the 3 in there, then again 4, 5, 6, 7, 8, 9, 10, 11, 12. We've still got a 12, so 30, 36 would be an average of 3. So if this was 38 or 39, it would be still an average of 3 and 1 left over. So really, can this be 3? And almost I need proof that this can't be 3. Well, if that is 3, then that is 9. Okay, and that creates possible problem. So if we start to think about minimums, so 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, because these are going to be different, 20, 21, 22, 23, 24, 25, 29. Oh, so that actually could add up to 29. That's a little disappointing. So, if this was 9 then, 29, because that was the minimum, so I don't think it can be 8. If this was 9, what's it going to do to the rest of everything else going on here? If this was 9, well, we couldn't have 9 in this box. Therefore, we couldn't have the 9 in this column in this box. Therefore, the 9 would have to be there. Therefore, the 9 would actually have to be in here. And that would cause us a problem, because all the adding up I did around the lowest numbers and add a 9 to that, and we would get, rather than getting 38, I guess you could, no, 39, I guess you could replace the 3, so 36 plus 9, no, 26 plus 9 becomes, 35. So that's not going to work. So we know that that actually can't be 3, because otherwise the 9 ends up there. So this is 3. Okay. 3 in the corner. Now it relates to the song That's 3 in the Corner, of course, the very well known song, which all Sudoku solvers get excited about. But now 109 in this lot. Yeah, so now we've got a question 28. So now we've got a smaller number, but I think I've still got this assumption to make from here, that actually if 8 is in there, then 8 is in there, leaving 8 in there, which would put an 8 on here. So we could try to do that. That can't be 4. What you doing, GoodElk12? And the other thing that I'm missing is we've got a double there, which is 5, 6. Okay, there we go. So 5 and 6 in those. Even more makes it, yeah. Yeah, so if 8, yeah, it makes sense. Yeah. So if 8 is in here, then 8 needs to be in here. So the lowest these could be 3, 2, 1. So if we replace the 8, the 3 with 8, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 24. Okay, so we could go higher than that. 24 means we've got 4 more numbers we could put in there. We could put 8 on there, but 4 more numbers. So 8. So okay, so I put a 1 in there. So this can't be 8 or 9 because we've only got 4 numbers to go up. Yeah, a bit lost with that. So the theory is if 8 was on there, again, I don't think we can have an 8 in there or 9 in there because they would both be far too high. So a 9 is more than 4 numbers. And what else could be in there? 1. Well, 1 can't be in there, or 9. Okay, so basically that is 2 because this has to be 8, 9. This has to be 8, 9. This has to be a 1. So what I've done is I've worked out that even if we put an 8 on here, we can't have numbers as big as 8 or 9 on the rest of the arrow. So what does that do to us? If this is 8, if this is 8, this becomes 9, this becomes 1. That is 3, so 3 is okay, but 1 on the 90, does that really work? So again, if we look at the 90, how many 12s go into 12 into 90 something? Okay, so my 12 times table isn't so hot, but I know that 6 times 12 is 60, yeah? 7 times 12 is 72, 84, 96. So 96. So it's 8 times 12, is it? 96. 9 times 12, 108. Is that right? 96. 108. Ten times 12, 120. Yeah. So 8 times. So it goes in 8 times. So again, that's really high. That's really high. So 120 minus 12 is 108. Minus 12 is 96. So 8 times is 96. So the assumption is that we've got to get... Now, nice thing to do here is to consider this. That these cells see each other. And therefore they've got to have different numbers in them. Another interesting little thing is the 4 cells lowest is 10, because 1, 2, 3 makes 6 and 4 makes 10, and the highest is let's give us a different colour set, is 30 on 4 cells. So I like killer Sudoku, one of my favourite kinds of Sudoku, and that involves adding up numbers in cages, which is nice. That yellow. But again, we've got these different digits that share common, so that for instance can be 17, which is 8 and 9. That can be 17, which is 8 and 9. So 20, 30, 34. This can be 17, except that can't be 8 or 9. So that can be 16. So 16, 34, 52. This is 30, 52 plus 30 is 82. 82 plus 9 and 9 could be 18. 82. So 90. 100. Is that really bad maths? I think that was really bad adding up. Is it really bad to say really bad maths? I think it probably is. So, but we can consider that. Now, we still need to kind of prove that 8, where that 8 is. Either the 8 is there, there, and there, or the 8 is there, and over here. And I said there's a 1 there. So I can start talking about if there was a 1 there. If there's an 8 there, I know there's got to be a 1 there. So I then know we haven't got 8 in here. So let's say we can have 29 out of that. 29, 30, 37, 37, 45 if that was 8, 45, 54 if that was 9, 63 if that was 9, 60, oh your mother, 63, 70, 72, 80, 89. So I think that cannot be a 1. Because that would only give us 89. Therefore, this would be maximum and minimum. So, there. So if that is maximum, we can then go, okay, this is 1. Okay, so this is minimum now. 2. No, not 3. 2, that's 1. So we're putting the minimum digit on this. So 1, 2, 3. So that is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23. 23. Beautiful. Okay, so the same thing would have to happen here. But if I go from the other end and I go 9, let's see how I can do with my 9s now. So we know that this must be 8 or 9. 8 or 9. So 9 plus 17 is 26, plus 9 is 35, plus 9 is 45, plus 8, 45, 53, plus 9, 53, 62, plus 7, 69, plus 69 plus 30 means I've added it up wrong, haven't I? But what have we got here? We've got 1, 2, 3, 4, 5 9s, 45 plus 30, 75, 82, 90, 98. Perfect. Yeah, so that is going to add up to 98. And now we know that this is 7. There is an 8 in one of these 3, and we know that there got to be a 9 in one of these 2. Okay, so what have we got left to do? We've got a lonely 5 sat there, which I think we can now fill in. And that's the wonder of these pencil marks. So 1, 2, 3, 4, 5, 6 needs to go somewhere. So there's 6. 8 needs to go somewhere. So now in this column we've got, is it 6? I try and go as quick as I can with these. So 1 in there. So does that add up correct? So that is 8. Yes, that works. That's good news. Okay. Oh, 2 and 1. 1 making 7. Yeah, that works. So next 2, 7 and 6 is missing from here. Can I put, so I can't put a 6 up there, so it must be there. Got these 8 9s, which leaves a 5 in there if there's no other 5. Double check, because sometimes when I quick I get it wrong. So 5s. So this 3. Okay, so we've got to have a 3 in the row. I can't be there, so that is our 3. We've got 8, so that is our 9 down there. So there's our 8 and 9 and 8 resolved. This is missing a 7, I believe. So that makes that 8, which makes that 9, which makes that 7. So we are missing a 6 from this row, and we are missing a 2 from that row. And what are we missing from the box? A 5. And in here we are missing a 4, was it? No, 4 is at the start. 5, 6, 7, 8. We're missing an 8. And in this box we're missing a 7. Okay, so that is 2 there, which makes sense. And this is going to be a 3 in the corner. Here we are, celebration. And that time I did it in 38 minutes 34. Now I've got to admit, this is the second time I've made a video of this one today, because I made a bit of a mess up on the ground earlier and didn't spot the 6, and I thought that 6 might really help us, because of course if that 6 wasn't there, then there would be room for an 8 or a 9 in this row apart from those. So I think that 6 was crucial. So I hope you enjoyed that solve anyway. Thank you, Momcraft42, for inspiring me to make this Douglas Adams inspired puzzle. Really enjoyed writing it, and I hope that some of you will have had a go and enjoyed this. Thank you for watching. My name is GoodElk12. Please like and subscribe. If you want to see more of this content, put in a comment. Thank you very much again, and I will say goodbye.